Next topic is blocks and closures in Ruby programming language. So here we are going to learn the concepts of blocks. What is a block or code block? How does a code block look like? And how does a block gets passed and executed? So those are the things we are going to talk about, and those are the most important things in this presentation. And we are also going to talk about proc and ampersand and lambda and closure. As long as you understand the blocks, that is good enough moving forward. Okay. So what is a block or code block? We are going to use these two terms interchangeably, block and code block. So what is a block? So block is basically a chunk of code. So you can think of it as a nameless function, like in JavaScript. You could have a nameless function, right? So you can think of it the same way. It's a chunk of code. Now, interesting thing is that you can pass this block, code block, a chunk of code, to another function as an argument. Okay, you can think of it as a special argument. And I'm going to call that another function that actually received this code block as an argument as a target function or target method in this presentation. Okay, so once the target function received this code block, then it can actually execute that code block. Okay, so the target function could perform iteration by passing one item at a time to the block. So this is an example. So in this case, we have array class object, and array class has each method. So this is in fact the target method. This target method is being received with this code block. Okay, so this is an example of code block. And this target method will in fact execute this code by passing, in this case, each item into an argument of this code block. Okay, so don't worry about this argument and things like that. So this might be a bit too difficult example in the beginning of the code block. So if you do not understand this code, don't worry about it. Okay, so we can actually digest this one more time later on. Okay, so how does a code block look like? So you have seen example of that already in the previous slide. So how you are going to create a block? Okay, so as I said, you can think of a block of chunk of code, and in Ruby you can create this block in two different formats. One is using this curly brace, typically for single line block, or if you have a multi-line code, you are going to use a do and end. So this is an example. So here we are passing this code block using this curly brace notation. So again, for single line code, you are going to typically use this curly brace. However, if you have a multi-line code, you are going to use a do end. Okay, so this is in fact the same thing, this one and this one. In this case, we have only a single line, but you can still use the do end code block. So this curly brace is considered as a code block, and this do end block is also considered a code block. So in this case, we have a single statement, but you could have as many statements as you like. Okay. Okay, now how does a block get passed and executed? So basically, I said a block will be passed to a target function, and target function or target method should be able to execute that code block, right? So that's basically what we are going to learn here. Okay, so when a method is invoked, a block is passed. So when the method is invoked, I'm going to call it again target method. When the target method is invoked, a block can be passed to that target method. So you can think of this code block as a special argument to that target method. Now, the way the target method can execute that passed block is by using yield method. So this is an example where we have defined my class, and it has a single method called the command. Okay, and then inside this command, it will call yield method. So because it doesn't have any arguments, you don't have to have a parenthesis, but you can have a parenthesis. So yield and yield parenthesis, the same thing. Okay. So when this command method is invoked with a code block, and inside this target method, if it calls yield, that code block gets executed at this point. Okay, so suppose we have created an object of my class. We're going to call new class method of my class here. So we have an object of my class. Then we are going to call command method, and then we pass code block. It's a chunk of code. So when this chunk of code gets passed to this command target method, the target method has a freedom to call that passed code block by calling yield method. So at this location, it will call passed code block. In this case, it's gonna just display hello world. Does this make sense? Any question on this slide? Okay, let's move on. Now, because code block is a chunk of code, it certainly can receive arguments, just like any other method, right? So in this case, suppose if we have defined a code block, the way you are going to create a code block with arguments is using this notation. You are going to specify vertical bar and the name of the argument and vertical bar, and then you can use that name of the argument in your code. So in this case, this code block is basically displaying that passed argument. Okay, so here we pass. So this is exactly the same code as previous slide. Okay, but in this case, we have created a code block that receives a single argument. So when we pass this code block as a special argument, when we are calling command one method of this guy, okay, now the yield method now can pass the actual argument value. So in this case, it's going to pass time.now. So this is going to provide the current time as an argument to this block. So that block will receive this time.now, the result of calling now method of time class, and that will be fed as an argument. So it will display current time and the actual time of this return value of time.now. Does this make sense? Question? Pretty straightforward, I'm hoping. So yield will execute the supplied code block, and because it is a code, you can certainly pass argument. In this case, we are passing just a single argument. Now you can certainly have, so this is another example. So going back to our each target methods, as I said before, array class has each method, right? So each is a target method. So when you call the each target method of array class, you can pass this code block which receive a single argument. So if you take a look at the source code of each method, you will be able to see is in fact taking each item and passing as an argument to this method in its yield method. Okay, so this code is the same as this guy. Here we are using curly brace. Here we are using do and method. Okay, so this is an example of existing method of existing class, each method of existing array class. And this is a case that we define our custom class called the my method, which contains a method called the command one, which is going to yield passing an argument, and then that argument will be passed as an argument in this code block. Okay, you can certainly have multiple arguments in your code block. Okay, so here we are going to call a target method called the test yield, and this code block has two arguments, arg1 and arg2, and all it does is basically displaying the values of those two arguments. And in this target method, it can call yield as many times it wants. Okay, so it could actually call yield. Every time it calls yield, it's basically executing the code block that was passed by passing these two arguments. So it will in fact display 1000 and Sang Shin, and here current time is, that's the first argument, and time done now is the second argument, and it will display current time is whatever. So this is an example where multiple arguments are defined in a code block. Does that make sense? Now, by having this kind of feature in Ruby, you can in fact have simplify the programming, and each is in fact a great example. If you try to do this in Java, basically it's rather difficult. Now Java 8 has the Lambda expression, so in Java you can do this now as well. But before Lambda support in Java 8, it was almost impossible to do this kind of simple syntax. Basically it was impossible to pass chunk of code to be sent around in Java before Lambda. Okay, and in Ruby and other modern programming languages such as JavaScript and Groovy, they all support these features, being able to pass a chunk of code as an argument. Okay, so let's do exercise 1. So same deal, you are going to get the zip file, you are going to unzip it, and you are going to read documentation to proceed. So I'm going to show you Ruby blocks exercise 1. That's what we are going to do. Yeah, so this is, basically, as you can see, exercises are pretty much what we have learned from the presentation. So this is the each target method, which is being passed the very simple chunk of code block, which receive a single argument. Okay, so when you run this guy, so by the way, this is the same thing as this guy. It basically displays each value. Okay, so Ruby block 2 format. So let's try that. Ruby block 2 format. Okay, so that's the code. And if I run it, and this is what we are going to see. So basically 1 2 3 1 2 3. So if I have another value like 4, and then if I run it, then you can see it's displaying the next number 4 as well. And I explained this, this code, and that's pretty much what I talked about as well during the presentation. And 1.2, how method is invoked executes a block called yield. So here we have custom class my class, and then in the command we just display this message, and then we are going to yield. Okay, and then we are calling this command method passing code block. Okay, so this is yield execute. Okay, so if I run it, and that's pretty much what I expected. Okay, so this is a case that we are actually passing 2 lines of code. So yes, if you, by the way, when you are using curly braces, if you try to actually have the same line, that's a syntax error. You have to actually have a different line. Okay, again, when you have a multi-line, you do not want to use this curly brace. Instead of, you want to use a do and end. Okay, and let me just change the format. Okay, I should actually have like this here. Okay, so if I run it, then it should display hello world and test. Okay, so you can certainly have this guy instead of here. You can have it right here. So as writer of method, you have a choice in terms of when you want to yield. So I'm going to actually yield it twice here, like this. Then it will display. It will invoke that the code block twice, here and here. Okay, and then we have this method in between. Okay. Okay. as that. And again, this is something we talked about already. Okay, so I don't know why we have that exercise one more. So this is an example. So in this case, yeah, so basically this is the execute block. Now what we want to do is we want to add this code. Okay, so this is an example where so I'm going to actually add this guy. Basically, if you take a look at this code, okay, we are going to inside command method is going to actually call another method in which is going to call another block. So the blocks there are two blocks involved. There is one block, and then we have inside is actually calling each method as well. Okay, so basically code blocks can be actually invoked in any places. Okay, anytime a method is invoked, you can pass the code block. Okay, so in this case we call command, and we are passing this code block. Okay, and then the yeah, so let's actually run this guy. Yeah, so basically we are getting to the same values here. Okay, yeah, so when we call this guy, this code block will be executed whenever you are calling yield, right? And inside that yield, we're actually calling another code block. So that's basically what we are trying to show here. Okay, and this is the same thing with this guy. Same deal. This one is the same thing. Same thing with this, because here we are using the curly brace. Okay. So basically we are instead of just having a very simple the code block, in this case we have a bit more complex code block. Okay, so in which code block itself could contain a code that calls another code block. That's basically the idea of this exercise. Let's see, that is okay, so 1.3, now we are dealing with a passing argument. Okay, so here we have a command 1 which received command 1 and command 2, and both cases, this is the case that it's not receiving any argument. I'm sorry, so command 1, there is no argument for that method, and then it's gonna just call the yield, and this is the argument that passed to the code block argument, and the same thing for this guy. Okay, all right, so when we run so the code block in this case receiving a single argument, so it will receive time now for this command 1, and in this case it will get the argument as my parameter that is being passed in the command 2. So in this case we're actually passing time.now as an argument, and that's the one that gets passed to the target code block, the passed code block. Okay, so and so that's command 2, pass, so it's pretty straightforward. And this is an example where we are receiving 2 arguments. Okay, so again this is the same code we have seen in the presentation. Okay guys, I am going to give you let's say I'll give you enough time for this exercise 1. This is in fact the most important part of this presentation, so I want you really actually do some experimentation of your own if you can. Okay, recording. Proc object. So the code block, even though it's being passed as a special argument, is not an object yet. Okay, so proc object is basically you can create a real first class object from a code block, and that object is called the proc object. So proc objects, sometimes we call procs, are blocks of code that have been converted into objects, and then these objects are callable or executable. So as I said, these proc objects are considered as a first class object in Ruby, just like a string object or person object or address object, because they can be now created during runtime, and it can be assigned into a variable, just like a string object can be assigned into a local variable, or it can be passed as an argument to functions, just like a string object is being passed as an argument. We were able to pass code block as a special argument. That special argument has to be at the end of at the end of the method, right? But if you want to pass code block as just a first class object like a string object, then you need to convert it into prog object. Then it's like just another object, and it could be returned as a return value of functions, just like string object is a string object could be a return value. Okay, so once you have captured that code block, meaning once you converted that block of code, a code block, into prog object, now in order to execute that object, meaning invoke that object, you are going to use a call method, instead of yield. So yield is for code block, to execute the code block in the target method. Prog object, once you got the prog object, it's just like any other object, but the contents it maintains, basically contains that chunk of code as well. So in order to execute that chunk of code in the prog object, you are going to use a call method. So let's see an example. So let's see how you can create a prog object from code block. So this is the way you can create prog object from code block. So here you are going to use a new method of prog class, and you pass code block. Then it will create prog object and assign into say hi variable. So this say hi variable is now pointing to an object which contains the actual code of this. So in order to execute, or in order to invoke that code, you are going to use a call method. So this call method is basically from prog class. You can also have these two lines of code combined into a single line. So I can create this prog object, and then I can call that call method. So this is the same thing as this. In this case, I created say hi intermediate variable. In this case, I created prog object and then call right away. So when you run this two code, here is going to display hello Sydney. In this case, it will display hello Boston. Okay, how to pass a prog object as an argument? You can pass a prog object as an argument just like any other object. So you don't have to pass this one at the end of a method like code block, real code block, but you can pass it as a first argument, second argument. It doesn't matter. It's just like it just works as just like any other object. Okay, so let's see an example. So here we have created prog object. And my prog is a variable that points to prog object, and that prog object contains this code. Basically just display argument. Now we have defined a method, and this method will receive two arguments. I just happen to name it as a prog param, just to be clarifying, just to be clear in terms of seeing this code, but you can just name it as A. And then you can call method, and because this is calling a chunk of code, and you can actually pass as an argument as well. So in this case, that chunk of code is receiving one argument, which is X, so I'm passing B as an argument. So this is basically a method in which is receiving two arguments, and each of these arguments could be in fact prog object. And in this case, the first one happened to be prog object, and then we're actually calling it. Or you can even actually pass that prog object directly, in this case, like a foo method. So we defined the foo method. Sorry about that. We defined the foo method, then we are basically calling that foo method, passing my prog object. So does this code make sense? So we created a prog object from a block, and then we define a method that receives an argument, and then we are passing this prog object as an argument. And inside this method, basically, we are going to use that prog object to call the code that it contains, passing a single argument. Any questions on this slide? Okay, so if you are from Java background, this might be a little bit strange. Or if you have actually exposure to Java 8 Lambda, then it might not be that much strange. But if you're actually coming from JavaScript background or other modern programming languages that support closure, this is not that much different from those concepts in those languages. Okay. Now, how to pass arguments to a block represented by prog object. So we have already seen this example. So in fact, I'm actually emphasizing it. So here, the code block that is used to create this prog object receive a single argument, and basically, when we call that method, we can pass argument. Okay, so this is the same code as this. Okay, I'm just emphasizing argument aspect of it. Okay, so that is a case that we are actually passing prog object as an argument. Okay, now let's take a look at the case where we are using prog object as a return value, just like a string object can be used as a return value. Okay, so here we defined gen times method, and it's receiving factor as an argument. Okay, so here we are returning prog object. So remember, the return value is the expression, I would say the evaluation of the last statement. In this case, we have a last statement. We have a single statement. So this will be evaluated. If you evaluate this guy, it's basically creating a prog object, right, from this code. So when you call gen times, it's actually returning prog object. So this is an example where prog object is being used as a return object. Okay. All right, so now we have defined gen times, which returns a prog object when it gets called. So we're going to actually call this. We're going to call it gen times, and it's going to return this prog object. So times 3 is a variable that points to prog object. Okay, so now because it's a prog object, we should be able to call and passing an argument. Make sense? Okay, question from Terry. And the order does not matter. Let me see. When you are saying order, what do you mean by that? Oh, whether this prog can be before B or after B? Yeah, absolutely. It's just you can actually use prog object just like any other object. You can actually pass it any the allocation of your the argument list, if that's what you are asking, Terry. Any other questions? So this is an example where we are using prog object as a return value. Okay, and we have already seen the prog object is being assigned into a variable. I mean, that's actually so here this is an example where create a prog object and we assign into a variable. So when I say prog object is a first class object, as I mentioned in the beginning, basically you can assign that object into a variable, just like a string object can be assigned into a variable. You can pass it as an argument to methods or functions, just like a string object can be passed as an argument. It could be returned as a return value of methods or functions, just like a string object can be returned as a return value. So that is the reason I say prog object is a first class object. Okay, all right, it just happened to contain the code. Okay, all right, so that is we talked about that. Yeah, return value. Okay, moving forward. Now, prog object works as a closure. So, how many of you have heard closure or have a general concept of closure? Anybody? Anybody wants to explain what a closure is? let me answer a question from Terry first. When you call it a variable, is that really a variable or string object? So I think you're talking about this case. So here, I created a proc object and assigned into my proc variable. Okay, so if you in fact try to see the class of it, it will display proc. So let me actually, let's actually try that. Okay, so here I'm gonna create my xyz equal proc dot new, and I'm gonna just have this method. Okay, and then you can see this is a proc object, so I'm going to display puts my xyz dot class. So you can see the type of that object is proc. Okay, all right. Let's see. Let me see whether that answered your question. When you call it a variable, is that really variable or string object? Yeah, it's actually type of proc. Okay, so Terry said closure is a stateless program. I'm not sure whether that explains what a closure is. Anybody else wants to explain what a closure is? Okay, so let's move forward. Proc object works as a closure. So proc objects are blocks of code that have been bound to a set of local variables. So when the proc object gets created, okay, at the time it is created, the object gets created, any local variables in the same scope will be captured as part of the object. Okay, so that's basically sometimes what people explain, the internal behavior of a closure. So once bound, the code may be called in different context and still access those variables. Okay, actually I thought I actually changed this code a bit to be more clear. Let's see, actually slide 20. Let me just hold a second. Yeah, looks like I didn't actually create a PDF file. So let me just I'm gonna use the slide and slide number 20. Oh, okay, so this is the example I was looking at. Okay, so let me just view. Okay, so let's take a look at this code here. So we have defined the gen times method, and it received factor as an argument. Okay, now we have a local variable called mynum, and it's basically factor times 2. Okay, now when proc gets created, by the way, proc object does not get created here. It gets created only when this method is invoked. Okay, because you can think of this is just a definition of a method. Okay, so this method will be executed only when it's invoked. So this proc object gets created only when this method gets invoked. Okay, so let's just see the definition of it. So we have a mynum, and basically we are creating proc object which receive a single argument of n, and basically it will multiply with a factor plus mynum. Okay, so this is shown to just display there are two local variables, factor and mynum. Those are considered as local variables when this proc object gets created. Okay, so let's take a look at this guy, gen times. So now when we are calling gen times method, okay, passing factor is 3, that is now mynum is set to factor times 2, so that mynum is going to be set to 6, right? So factor is set to 3, mynum is set to 6, and then we created a proc object. So as I said, when the proc object gets created, the local variables in the same scope, in this example, factor and mynum, will be maintained as part of that proc object. So when we call gen times, proc object gets created and assigned to time 3. So this time 3 is pointing to this proc object, and that proc object has remembered the fact that factor local variable is set to 3 and mynum is set to 6. So when we are calling this time3.call 12, so we are actually calling this proc object by using call method, we are passing 12. So this passing 12 is this the n number, so this is the being used as an argument. Okay, so the value it will return is 42 because 12 is n, but it remembers factor and mynum, which is 3 and 6. So it will actually multiply 12 times 3, so this guy, plus my number 6, so it will return 42. Because this proc object that is being pointed by time 3 remembered the values of factor is set to 3 and mynum set to 6. Now let's take a look at this example. So we are going to call gen times passing value of 5. So factor is 5, mynum is 10 because we set factor times 2. Then proc object gets created. So when this proc object gets created, the values of local variable of factor and mynum is now remembered as 5 and 10. So whenever you are using times 5 variable, which is pointing to proc object, that proc object, remember, the local variable factor is set to 5, mynum is set to 10. So here I'm using times 5 dot call, so with the value 4. So in this case, n is going to be set to 4. However, the factor and mynum local variables are still remembered as 5 and 10. So it will multiply 4 times 5, so this guy, this part, and then mynum is added, plus mynum, so 10, so it will be 30. Okay, now in this case we are going to call this guy first and then this guy. So we know that this is going to return 30, right? So now we are going to actually use a time 3. Okay, so it will be 96 because the n is set to 30, which is the value that we have here. And then it still remember this is a time 3 proc object. It remembered the factor is set to 3, mynum is set to 6, so it will return 96. Does this make sense? Anybody have a question? Okay. Yeah, so having this feature, you could actually have an interesting program to be written, and there are in fact several examples of like that. But yeah. So I just want to actually understand the mechanics of the closure first. Okay. All right. So let's move on to Lambda. So what is Lambda? So now Lambda is being supported in Java 8 as well. So basically the concept of Lambda has been around many years from the beginning of Lambda calculus. Okay, so Lambda is the same thing as proc.new. So you can create the proc object like a proc.new like this. By the way, you can also use the proc method. So this is from the class, I guess, or object class. So this is the same thing as this. Or you can actually use a lambda. So all these guys are in fact the same thing, and the lambda expression could be specified with this notation as well. Okay, so this is supported from Ruby 1.9. So all 4 of these are the same thing. Okay, so in Java, in fact, we are using this notation, right? Okay. There are some slight differences between this notation versus this, but for now, for our purposes, you can think of them the same things. Okay, so that is exercise 2. So let's take a look at the exercise 2. Basically, this is the same code that you have seen. Okay, so I'm gonna just move forward. All right. return value, and then this is the an argument. Okay. So yeah, so this is the we created two proc object, proc A, proc B, and oh, this is a case that we are passing proc object as an argument. So we actually, proc object, and we are just calling. Okay. And then we are using Lambda. Okay. All right. So this is the same thing as proc.new, and this is the you can use the this notation as well. Okay. You can certainly use you create the Lambda, then calls, the same deal, and you can use this notation as well. Okay. All right. So pretty straightforward. Okay, so I'm going to give you guys about 10 minutes to try this exercise, exercise 2. Next topic is ampersand operator. So what is ampersand operator is for? So basically ampersand operator is used to convert between blocks and proc object. Okay, so you can use ampersand operator to convert from a block to proc, or you can use ampersand operator from proc to block. Okay. All right. So in the case of converting a block to proc, so if ampersand operator is prepended to the last argument of in the argument list of a method, the block attached to this method is converted to proc object and gets assigned to the last argument. So I'm going to actually explain this using an example. And that is a case for converting from a block to proc. And you can also convert a proc to block object. So another use of ampersand is the other way conversion, converting a proc to a block. So this is useful because many of Ruby's built-in methods, especially the iterators, expect to receive a block as an argument, and sometimes it's much more convenient to pass them as a block. So what it means is this: whenever there are existing method that you want to use, and those existing method are expecting a block rather than a proc object, then you want to convert whatever proc object you happen to have into a block. Okay. And vice versa is also true. If you happen to have a method that expected a proc object, but you happen to have already a block that contains chunk of code, then you can convert it to proc object using ampersand. So let's see an example of this. So this is the first conversion, is from a block to a proc. Okay. So we have a method called myMethod ampersand. So you can name it in any way you want. I just happen to name it as a myMethod ampersand. And if the last argument is set with the ampersand, okay, and then if you pass the a block to this method, so this is a case that I am calling my method ampersand, and then it's passing, the first argument is set to A here, okay, and then you are passing a block. Now if you define your method notation like this, basically it will take this block and then convert it into a proc object. That proc object is going to be represented by F. So now you should be able to call f.call, and I can pass an argument because this code block receives a single argument. Or or in this case, but yield also works as well. So I can still call yield, just receiving this guy as a block. Okay, so this is the ampersand usage of ampersand on the last argument of a method, and it is basically converting a block into a proc object. Okay, let's see the other direction. So this is the case that we are converting from proc object to a block. Okay, so we have a proc object. So we have created proc object and assigned to say hi. Okay, Now we have do it with a block method. So this is the existing method by some third-party vendor. Somehow, it receives only a block. It doesn't receive a prog object. But you happen to have code that captures this chunk of code. You already have a prog object that captures this chunk of code as a prog object. So what you want to do is you want to convert that prog object into a code block. So in this case, you're going to call do it with the block, and then you are going to convert this say hi prog object into a block by using ampersand. Okay, so that is exercise 3. So let's take a look at the exercise 3. So this is exactly the same example that I showed you in the slide. So I'm going to actually let you play around it. Okay. All right. I'm going to actually continue the presentation of this. I'm going to continue the presentation of the remaining part of the this presentation, and I'll give you guys a chunk of lab time. So where do blocks get used? Okay, so these are examples where the blocks could be used. Again, by using these blocks, your coding can be, in fact, abstracted out or simplified. So we have already seen examples of using each method, receiving this chunk of code. This chunk of code is being executed for each of these elements. Okay, so again, in Java, before Java 8, in order to do these things, you have to in fact create a for loop and all those, the boilerplate code that doesn't actually do anything much in terms of the business logic. It basically complicates things. Okay, so this is a lot simpler code. Resource management, basically, you are going to open the file and then you pass a chunk of code and you are going to read it. Okay. Callback could be also handled through this chunk of code. So we are going to call on button press method, then it receive a chunk of code. So when something happens, it will actually invoke this event handler. Okay, so that's exercise 4. So basically we are gonna try the few iteration examples. So here we have defined my method, and this is the case. Okay, so now it's actually receiving block but convert into prog object with the ampersand sign. So because it's a prog object, we are going to use a call method of that prog object. Okay, and so in this case, my method 5, and basically receiving 2 arguments, and we are just displaying these values. Okay, so basically we can actually call 1 2 3 4 5, and we are basically creating a new value. Okay, and iteration 2. So here so basically we have a repeater class, and we have initialization code in which we receive this block of code and we convert into a prog object. Okay, and we are assigning this prog object into a block instance variable. So this is an example where we are in fact the assigning prog object into a variable, in this case instance variable, and we have a repeat method, and basically we are just calling it. Okay, so 5 times 2 repeater that repeat, and so this is a little bit artificial code, and the purpose of this code is to show how simplified things could be in terms of doing iteration. But if you don't understand this code, think about each method of array class, or each key method, each value method of hash class. I mean, those are a lot simpler by just receiving the chunk of code. Okay, right? So that is actually good enough. If you have that understanding, that should be good enough moving forward. Okay. All right. So let me just